Welcome to the DIY Honda Garage channel. DTC P0128 refers to a malfunction within the cooling system of the 2023 Plus Honda CR-V. This code is triggered when the Engine Control Module, ECM, also known as the PCM, Powertrain Control Module, detects that the coolant temperature is not reaching or maintaining the expected operational levels. In specific terms, the issue arises when the temperature from ECT, Engine Coolant Temperature, Sensor 2, rises immediately after starting the engine, or if ECT Sensor 1 fails to reach a designated temperature threshold. This could indicate problems with critical components, such as the thermostat, radiator fan, AC condenser fan, or potentially the PCM itself. Conducting thorough diagnostics is crucial due to the myriad of components linked to the vehicle's cooling system that affect performance and can lead to significant engine issues if not addressed timely. The DTC P0128 code points to a malfunction in the cooling system, primarily involving the engine coolant temperature, ECT sensors located in the engine bay. ECT Sensor 1 and ECT Sensor 2 play crucial roles in monitoring coolant temperatures to ensure effective engine operation and optimal performance. The sensors relay temperature data to the PCM, which relies on this information to adjust engine parameters accordingly. If ECT Sensor 1 doesn't reach the required temperature, or if ECT Sensor 2's readings fluctuate unexpectedly, the PCM recognizes this as an abnormality, triggering the DTC. The thermostat, which regulates coolant flow and temperature, along with the radiator fan and AC condenser fan, are pivotal components in maintaining appropriate engine temperature. Each of these components' positions and functions influences how heat is managed within the engine. When diagnosing DTC P0128, it is essential to consider several potential causes. A faulty thermostat is one primary suspect, as it directly affects the engine's ability to regulate coolant temperature efficiently. If the thermostat is stuck open, it may prevent the coolant from reaching the ideal operating temperature, thereby triggering the DTC. Additionally, ECT sensor failures can yield inaccurate readings, leading the PCM to misinterpret the engine's temperature. A malfunctioning PCM itself could also be the root of the issue, as it processes signals from various sensors to manage engine performance. Other causes include possible blockages in the cooling system that hinder coolant flow, and various electrical issues such as wiring faults or connector problems that could affect sensor performance. Each of these components must be investigated to accurately pinpoint the source of the problem. The symptoms associated with DTC P0128 can significantly impact both the driving experience and the engine's longevity. A prominent symptom is engine overheating, which could lead to severe engine damage if not addressed promptly. Poor engine performance may also be noticed, as the PCM adjusts engine parameters based on incorrect temperature readings, resulting in sluggish acceleration or reduced power. Drivers might observe false engine temperature readings on the dashboard, leading to confusion regarding the vehicle's operational status. Additionally, increased fuel consumption could occur due to the engine running inefficiently, further compounding the problem. Recognizing these symptoms early enables a timely diagnosis, preventing extensive damage and costly repairs. The first step in troubleshooting DTC P0128 involves allowing the engine to cool down until the coolant temperature drops to 104 degrees Fahrenheit, 40 degrees Celsius or less. This ensures safety and accuracy when after recording the initial temperature values, proceed to start the engine and let it idle. Monitoring the ECT sensor readings during this phase is crucial as the engine heats up. Specifically, Watch for an increase in ECT sensor 1's temperature that should ideally rise by 40 degrees Fahrenheit or 22 degrees Celsius or more from the baseline established in the previous step. At the same time, observe ECT sensor 2's reading, a rise of 13 degrees Fahrenheit or 7 degrees Celsius or more from the initial recording is also a key marker. If both of these conditions are met, the failure has been successfully duplicated, indicating that there may be an underlying problem with the cooling system or its related components that needs further investigation. The next phase of the troubleshooting process involves conducting a thermostat test to determine its operational effectiveness. Given that the thermostat controls the flow of coolant, verifying its proper function is essential. A thermostat that is stuck open can result in inadequate heating, while one that is stuck closed may cause overheating. Observing any irregularities in coolant flow during this test can provide insights into potential cooling system failings. If the thermostat appears to operate normally, attention should turn to other components in the cooling system for potential blockages or inefficiencies. Properly diagnosing the thermostat's functionality can narrow down the list of potential causes linked to DTC P0128. Conducting a comprehensive engine cooling system test is necessary to identify additional symptoms beyond those observed via the ECT sensors. During this evaluation, check for any cooling system issues like leaks, blockages, or faulty components that may contribute to abnormal temperature readings. Systematic inspection of hoses, coolant passages, and any related components will help in determining if they impede the flow of coolant. If blockages are detected, they may need to be cleared. Identifying leaks is also critical, as they can lead to insufficient coolant levels, resulting in overheating and triggering the DTC. The thorough investigation of the cooling system will directly link to resolving the P0128 warning. Finally, if prior tests rule out the thermostat and cooling system as potential problems, inspect the powertrain control module, PCM, itself. The PCM is responsible for interpreting data from the ECT sensors and controlling engine functions based on that data. If the previous diagnostics normalize, but the DTC persists, the PCM might be at fault. Conduct a thorough diagnosis to check for any electronic failures or communication issues within the module. Ensure all electrical connections associated with the PCM are secure and operating correctly. A malfunctioning PCM can significantly skew sensor readings and adversely affect engine performance, necessitating a detailed review. Once repairs are completed, it is imperative to conduct a final verification to ensure that the issue related to DTC P0128 has been resolved. Begin by confirming that all repairs made address the initial symptoms and underlying causes identified throughout the diagnostic process. Next, use the Honda Diagnostic System, HDS, to clear the stored DTC from the vehicle's memory. This step resets the system and allows you to evaluate whether the DTC reappears. Finally, take the vehicle on a test drive to monitor its performance under real-world conditions. Observing that there are no persisting symptoms or warning lights will confirm that repairs were effective. Implementing preventive maintenance on the cooling system is vital to ensuring long-term vehicle reliability and performance. Regular cooling system checks help to identify potential issues before they escalate into significant problems. Maintaining appropriate coolant levels is essential, as low coolant can lead to overheating and damage to engine components. Additionally, it is advised to inspect the thermostat regularly for function, ensuring it opens and closes as intended to regulate coolant flow effectively. Consider testing the ECT sensors periodically, as sensors can wear over time and lose their accuracy. A proactive approach to cooling system maintenance not only minimizes the chances of triggering DTC P0128, but also enhances overall engine efficiency. In summary, DTC P0128 points to an underlying cooling system malfunction that demands thorough diagnostics. The issue may stem from various potential sources, including faulty thermostats, failing ECT sensors, or even the PCM itself. Each component plays an essential role in maintaining the engine's temperature and performance. It's important to diligently follow the outlined troubleshooting steps to accurately diagnose and resolve the problem. Ultimately, implementing preventive maintenance can significantly reduce the likelihood of encountering similar issues in the future. Ensuring the health of the cooling system is paramount for the overall longevity and performance of the Honda CR-V. Please like and subscribe to the channel. See you next time.